Today we're going to be taking a look at the Fermi Paradox, the apparent contradiction between the sheer size and age of the universe and the seeming absence of any other intelligent life in it besides what resides on our own little pale blue dot. As big and old as the universe is, we'd expect life to have popped up elsewhere many times, and frequently long before it did here on Earth, yet we've never found a single bit of evidence of it. That's the Fermi Paradox, and down the years a lot of explanations have been suggested for it. This is not our first visit to this topic, but I thought it was time to redo the original video to look at some of the areas we skimmed over in the original video. Our goal today is to look at every solution we know of that's either considered pretty logically consistent or popular, and to look at the strengths and weaknesses of each proposed solution. To do that in anything approaching a reasonable period of time, even by the standards of this channel, we will have to move through the material pretty quickly, which is why some of these subjects have their own separate videos, and why you often see little white and yellow boxes popping up with video links. And since some folks find me hard to understand, you may want to turn on the closed caption subtitles for this video, which is usually right down there by the subscribe button. Also, while there are probably about 100 Fermi Paradox solutions I'm personally familiar with, an awful lot of them resemble each other greatly and share many or all of the same strengths and weaknesses, so I will be lumping them together into categories and subcategories. As I said in the original video, any given categorization system is going to be pretty arbitrary, so I've gone ahead and changed them up a little bit this time around. All four categories remain basically the same, even if the subcategories have not. Those were: Category 1. Alien civilizations are rare, so we haven't detected them. Life, or at least intelligent life, just isn't very common in the universe. We can't see it because there's just not much of it to see, maybe none at all. This has quite a few variations, including everything from even simple life being incredibly uncommon, to technological civilizations self-destructing. Category 2. Alien civilizations aren't rare, but we can't detect them. Now this is a broad zone, and often touches into Category 1 as well, since many of the solutions still assume alien civilizations aren't super common. They don't talk to us because they don't want to. They see it as a waste of time. They don't want to interfere in our culture. They all talk using something better than radio signals. They don't even talk to each other, and many others. This is probably the broadest category in terms of solutions. Category 3. Alien civilizations aren't rare, but we can't recognize them. I use the word recognize here in both of its usual meanings. First, we might mean something so alien we can't even tell it's intelligent, or second, we might not recognize them in terms of acknowledging them officially. This is the category for the very bizarre aliens, or for the aliens walk among us, but we don't believe it. Category number 4, self-explanatory, miscellaneous. Some of the stuff in this category just doesn't fit into the others, or maybe could, but is better off with its own separate mention. Last time I spent most of it in Category 2, and number 4 was the runner-up. In this updated version, I want to spend more time on Category number 1, especially the first two subcategories. We're going to be here for a while, so a snack and a drink might be advisable. But, with no further ado, let's talk Category 1. Category 1. Alien civilizations are rare. This is the broad category that rests on the idea that our lack of evidence of aliens is simply due to them just not being very common. Quite a few of the solutions in other categories assume they're not very common too, but that's a relative term and not their main argument. For Category number 1, that is the main argument, but it still breaks down into multiple subcategories. In this version of the video, I've broken it into 4. Category 1A, Rare Earth. Life itself is incredibly rare because planets that can birth and support life long enough for it to evolve are rare. Category 1B, The Great Filter. This extends on the notion planets can support life are very rare, but places a bigger focus on the improbabilities of intelligent life evolving and developing technology. Category 1C, Civilizations don't last long. This category usually assumes technological civilizations aren't too common in the first place, but that few if any will last long before destroying themselves, and not long enough to get out and colonize other stars. Category 1D, Intelligent life is not naturally occurring. This tends to be the catch-all area for solutions that revolve around the notion that either life itself, or intelligent life specifically, is either astronomically improbable or outright impossible to form on its own. Now as we begin exploring these notions, I'm going to bring in a counter. Every time I bring up a new item which might plausibly be unlikely in the development of technological civilizations that have gotten themselves out into space to colonize it, I'll add 1 to a counter. For instance, some stars may have been so inimical to life ever forming there because they put out a lot of hard radiation. Now this counter we'll use at the end for our own hit on Drake's equation. Not in a rigorous fashion though, because we'll just assume every hit on the counter is coin flip odds, 50-50 proposition. Some of these are probably way less likely than that, such as a solar system having an Earth-mass planet in the habitable zone. Others might be better than 50-50, like the evolution of multicellular life, which appears to have happened several times independently on Earth. We'll just hand-wave them all as averaging out to 50-50, since this is only to illustrate a point. And we'll talk a bit more about Drake's equation at the end of Category 1 as well. Unfortunately, we're really going to have to speed through these because I got up to 12 pages or 30 minutes of video on them just giving brief descriptions, so we'll be bypassing that in favor of me just stating the obvious ones. But I want to emphasize, while I don't always agree with the reasoning or probability for some of these, nothing went on this list without a good reason, and I'll add more details on the slides, but you'll likely need to pause the video unless you're a speed reader. Also, while some of these massively drop the odds, acting as an actual hurdle you can't pass, others fundamentally put a time on things. If you don't develop it in time, your planet burns up. The Sun has 5 billion years left before it goes red giant, but stars get progressively hotter as they age, and we'd estimate the Earth will be uninhabitable in as little as 300 million more years. Keep in mind that while the board has been around for 4.5 billion years, and life for all but maybe the first 400 or 500 million years of that, the first land life and first super brains only developed about that long ago. If our Sun was just 5% more massive, its lifetime would have shrunk enough to render Earth uninhabitable by now. So time's a factor, and since in the long term, evolution can be thought of as a statistical process where X number of mutations need to occur, anything that makes an organism take longer between generations, or decreases the number of those organisms, and therefore increase the timeline for those mutations to occur on average, has to be considered to be a filter in itself. Colder worlds, or smaller worlds, would probably have this problem, and while plenty of stars live longer than our own, in fact most do, besides having their own unique problems for supporting life, they might not have developed complex life yet. Okay, let's get started. Category 1A, Rare Earth. Life itself is incredibly rare because planets that can birth and support life long enough for it to evolve are rare. Earth is quite different from its neighboring planets, and our solar system differs from its neighbors. Likely every solar system in the universe is unique to some degree. But over the years, we've noted a lot of features our planets and our solar system have, and even our area of the galaxy has, which might make life easier here than most places. Now, a lot of these individual points are debated, and it's very hard to apply a genuine probability to many of them, which is why we'll be using our hand wave of 50-50. Now, I don't always agree with the odds on these, but as mentioned, I usually won't add one unless someone has written a pretty convincing treatment on it, and usually one making it worse than 50-50. The rare Earth hypothesis holds that all of these add up to an improbability that is very high. Now, as I mentioned, all categories are somewhat arbitrary, so it isn't like our second subcategory, Great Filters, doesn't include these more physical barriers to life, or that the rare Earth hypothesis bypasses the evolutionary ones, nor do the other categories ignore them, but it's more about the key focus. So what could make Earth abnormally hospitable to life? Well, let's zoom in from the universe scale. 1. Old enough galaxies. Many early galaxies are very active, with stuff like quasars. That would make life anywhere in it tough at best, and they take different times to settle down. 2. No metals. Buildup of heavy elements from supernova takes a while and is lower in the outer rims of galaxies. Number 3. Too much galactic radiation. The places near the center of the galaxy, with the most metals, are saturated with hard radiation. 4. Galactic dead zones. The core isn't the only place with too much radiation, or too high a density of stars for stable solar systems to be very likely. 5. Stable galactic orbit. Lots of solar systems wander the galaxy in much more elliptical orbits than we do, popping in and out of those danger zones. 6. Wrong sun. Big stars don't live long enough. Small ones have their own problems, especially much smaller red dwarfs as we looked at in the Habitable Planet series. 7. Suns fluctuate too much. A big one. Our sun is freakishly stable in its power output compared to most stars. 8. Solo sun. Life around binary stars is plausible, but it does have problems. 9. Habitable zone. Loosely defined as where it's not too hot and not too cold for liquid water, unsurprisingly known as the Goldilocks zone. Needless to say, most planets are not in it. 10. Stable habitable zone. As I mentioned, stars get hotter with time, and the habitable zone moves. A planet needs to be in it the whole time. 11. Eccentric orbits. Planets orbit in ellipses, not circles. If you're too elliptical, you freeze at the aphelion and burn at the perihelion. 12. Vacuum cleaner Jupiter. Solar systems have a lot of debris. Getting hit by it can sterilize a planet. Big gas giants out beyond your planet can minimize this by sucking them up. 13. No hot Jupiters. If you've got a big planet close to the Sun, it can seriously screw with the orbits of other planets nearby in the habitable zone. We've found tons of these so far, so they are not rare. 14. Asteroid strikes. Plenty gets past your Jovian vacuum cleaner if it's a big enough one that can sterilize a planet, not just kill off a lot of stuff, and we think ones considerably bigger did hit us to make the moon. 15. Large moons. Traditionally a popular great filter, we now have reason to believe rocky planets with large moons might be as common as 1 in 10, but its value to life remains unchanged, especially the effect on tides and tectonics. 16. Making large moons. That collision theory for the moon being created, and the huge heat pulse involved, along with the stripping of the primordial crust when it was tossed into orbit, is also a fairly popular new great filter. We might be nothing but a water-covered planet otherwise with no real plate tectonics. 17. Not enough plate tectonics. 18. Too much tectonics. 19. Planet too massive. High gravity, thick atmosphere, probably deeper oceans. Sunlight might not get through for photosynthesis, and there may be little or no land. 20. Planet not massive enough. In the terraforming video, we discussed the problems with keeping an atmosphere on lighter worlds, and while Venus has a way thicker atmosphere than Earth, that doesn't make it easier for complex life to dwell there, and there's very little hydrogen and water on Venus compared to Earth. Too little gravity means less water, or a quarter planet to keep that hydrogen, like Mars. 21. Magnetic field. Planets need these to protect them from radiation and to keep their atmosphere, or at least their hydrogen. Ours is produced by a large and molten core. It need not be a lot weaker to make life a lot harder. 22. Rotation rate. Our planet used to spin about twice as fast as now, with 12-hour days, and we have the moon to thank for slowing that down. If a planet spins too fast, it will have too much violent weather, and subsequently erosion. Too much erosion, land disappears, and maybe more importantly, topsoil does. 23. Oxygen absorption. Oxygen is highly reactive, and early on, when it was a poisonous substance to life, it got sequestered into rock and water. A change in a planet's crustal composition and turnover could prevent oxygen being absorbed fast enough to prevent life from being poisoned to death, or keep being absorbed so there's never enough oxygen to serve as a fuel for aerobic life. So that's rare Earth. If you're curious, we're up to 23 coin flips, and the odds of getting heads 23 times in a row is about 1 in 8 million. That would happen about 50,000 times in a galaxy of 400 billion stars like our own. Now those favoring planet conditions as the main bar for life developing will, quite fairly, point out that my 50-50 standard here is overall way too kind. Many of these would be more like 1 in 100, worth 6 or 7 coin flips all on their own. If we said these were more like 1 in 6, the odds on dice, not 50-50 coin flips, well, 6 to the 23rd power is about 800 quadrillion, which is about 3 times as many stars as there are within a billion light-year radius of us, or from which we receive light less than a billion years old. So this camp is hardly without its merits. Now as I mentioned, there's no cutoff between rare Earth and our next category, the Great Filter. So those who feel physical conditions aren't quite enough, just keep going into these. Category 1b, the Great Filter, often actually refers to a single specific hurdle that is the biggest problem for life developing, but just as often means many of them. One of those previously mentioned conditions might be 1 in 1,000, while 10 others were 50-50, and that lone filter, 1 in 1,000, would knock out just as many competitors as those other 10 combined. Sometimes someone will mean a great filter, one of these filters thought to be especially low odds, but usually it just means as the sum total, and today I'm mostly using it to describe evolutionary hurdles, biological or more sociological ones near the end. Okay, we left off at 23, let's continue. 24. Abiogenesis. We still aren't sure how it happened or where. Popular candidates are tidal pools, underwater thermal vents, and even outer space. We know it ought to take a decent chemical soup with some sort of energy flux through it, and probably many concentrations and mixtures can do it, but not likely all with similar odds. It might be some mixtures are way less likely, astronomically so, than very similar ones, to produce life. I've seen some attempts to calculate this, but they're pretty weak. One often cited write-up used the entire volume of the ocean, not tidal pools or volumes near underwater vents, then still had the ocean volume 1,000 times higher than it was then or now. One of the reasons why peer review is so important. 25. Staying alive. From what we can tell, conditions on Earth when abiogenesis happened were nothing like now, and life has to make that conversion or die. The way the Earth was back then would not be hospitable to complex life. 26. Simplest cells. Protocells, the boundary in many eyes between living and non-living material, revolve around the cell wall or membrane, and is now thought to be the first step, with lots of interesting research on the subject in the last decade, even showing how the assembly of these membranes would logically act in a Darwinian manner. 27. Prokaryotes. Cells with no nucleus or organelles, these are still light years more advanced than self-replicating molecules or even protocells, and they took a long time to develop. So again, our slower generations or smaller population concern of slowing things down is a concern. 28. Photosynthesis. Our planet, and our modern ecosystem, gets virtually all its energy from the sun. Until life learns to convert sunlight directly into a power source, it is going to be very small and slow. It's a lot easier to have a lottery winner out of 1 million people who play every day than 1,000 people who play once a year. And many worlds might never get there because their atmospheres are too thick and cloudy for sunlight to penetrate. Or conversely, because their atmosphere is too thin and magnetic field too weak, so that life gets blasted by radiation if it tries to exist where sunlight reaches. Photosynthesis is often viewed as a strong filter, not because it is an improbable mutation, there are many routes to many different types of photosynthesis, but rather because on many worlds it would not be practical to develop. 29. Eukaryotes. It is a big step to go from a simple cell to one with a nucleus and even more specialized parts. Eukaryotes, in addition to that nucleus, have organelles, specialized machines that do jobs that would not let them survive without being part of an interdependent totality. Indeed, mitochondria, a vital component of modern cells, isn't even a true part of the cells they are in. 30. Colony organisms and multicellular life. Complex life is a pretty arbitrary concept, but this is often the line drawn for it. At some point you begin getting serious cooperation between cells. This is not a good Fermi Paradox filter though, since we believe this has happened independently on Earth many times, but it's still a good inclusion because it adds a lot of time. Even if it would probably be a common and near inevitable route for life to take, it will add many mutations and generations to get there, and introduces its own survival problems like cancer. 31. Oxygen crisis. As I mentioned, Earth didn't always have an oxygen-nitrogen atmosphere, and its initial emergence was as a poison, a waste product of life mostly tied to photosynthesis. 32. Oxygen breathing. Breathing oxygen is a huge advantage. Like photosynthesis, learning to live with oxygen as an anaerobic organism isn't the same as learning to breathe it. 33. Sexual reproduction. This is a big one and still quite a mystery, especially in male and female divergence, rather than just organisms that were non-gendered but just reproduced with others rather than subdividing. When you share DNA, you share mutations. If a cell starts off subdividing, and 20 generations later there's 1 million of them, of which 2 have developed a handy and non-mutually exclusive mutation, they can't share that mutation without some way of stealing each other's genes. 34. Food chains. An often overlooked one, but an important one since you need a certain density of life for this to be advantageous. Hard to live as a predator without a decent amount of prey. Our ability to eat other organisms for compact, high-energy fuel is a major advantage, and a double whammy to lower energy worlds since they would not only have the slower evolution from a smaller baseline population and longer generations, but would have problems supporting food chains. There's no advantage to eating others if you have to expend more energy going and finding them to eat them than you derive from eating them. 35. Land life. Life on land took quite a while, and as mentioned, it happened about as long ago as we have left before the world is uninhabitable. No land life, no fire, no technology. 36. Brains. As mentioned, these only started emerging about the same time land life emerged, and even those very simple brains were a big deal. We'll come back to brains again, but the simplest forms of them are a huge advantage. 37. Parents. Now obviously you've got this the moment you've got sexual reproduction, and arguably before that as well, but organisms that actually care for their young, and opt for fewer children, more investment per child route, is a major and non-obvious step in evolution. 38. Families. Another big step for eventual civilizations, not just parents who guard their eggs or watch over their young for a few days, but actual families where the parent or parents tend their young for a long while, and frequently stay together their whole life as a cooperative pack. 39. Tool use. 40. Language. 41. Fire. This is actually a big one since there is no technology without it. Yet fire on worlds with lower or higher oxygen could be useless or horribly dangerous, and many creatures gain little from it, and fire is always dangerous. 42. Caring for your elderly. Once you have language, actually feeding your elderly gives you someone to watch and teach your children who has a lifetime of skills, but otherwise might not be too useful for gathering food. 43. Farming. You just can't achieve the kind of population densities associated to civilization as hunter-gatherers, and what's more, it lets you be stationary, meaning you don't have to carry all your possessions around like your harvest. Food stockpiles let you support more people simply by having reserves for bad seasons or years. Of course, some planets might not even have noticeable seasons, which sounds good, no hard winters, but necessity is the mother of invention. 44. Metal. Metal isn't as initially useful as people assume. A good stone blade is actually sharper than anything but our best modern steel, and you need some serious technology to make steel. We've been using fire to make pottery for 30,000 years, yet even copper wasn't in use till 3000 BC. That's 25,000 years of using fire to cook food and clay vessels before figuring out metal. Remember, these folks are us now, just as smart, so if they needed that long to invent basic metallurgy, it can't be an easy step. 45. Writing. Unless these critters have near-perfect memories, which would require an even more expensive brain, you need a recordable language for complex civilizations. 46. Law and custom. A weird one, but once civilization arises, you need rules for dealing with strangers with some degree of trust normally afforded only your lifelong tribe members. I'm using this as a catch-all for everything from legal codes to money to etiquette, and if that last seems silly, think how we often react to those with bad or just foreign manners. 47. Scholars and philosophy. Having people who devote their whole life to learning things which have no immediate use, knowledge for its own sake, is an expensive thing and a big jump past the tribal elders and shamans, one that's often been rejected. 48. Science. You almost have to be trained formally in this to really appreciate how counterintuitive a thinking process this is, and how offensive it can be to authority. People don't appreciate when you tell them their folk medicine is wrong when they also have people who sincerely swear it saved their lives. Now we have two more that will give us an even 50, coincidentally but conveniently, but they are for our last category. 49 is not destroying ourselves with nukes and such, and 50, we actually colonize space. Most members of the Great Filter Camp do include those last two, but I feel they merit their own category. Incidentally, I don't have an official camp I'm in, but I tilt heavily to the Great Filter, 1B, as do most scientists I know who have spent time on the subject. That means I'm biased, of course, but here's why. We came up with 50 coin flips, and with just all 50-50 odds, that would mean to get to the end of the list, you'd have to get heads 50 times in a row. The odds of that are less than 1 in a quadrillion. That's about how many stars there are within 150 million light years of us. 1 sieve per every several thousand galaxies. And if we kick that up to using dice again, 1 in 6, that is 10 to the 39th, trillions of times more stars than in the entire known universe. Needless to say, even that 50-50 odds is pretty high, and makes intelligent life anywhere close enough for us to see very unlikely. Even my extension on this, the companion video The Dyson Dilemma, which lets us hunt for galaxy-spanning civilization a billion light years away, only requires that lower-end coin flip odds to be right to be justified. The flaw, of course, for both our first two subcategories is that we don't know what those odds are. Drake's equation, the loose and arguably outdated formula for calculating the odds of detecting intelligent life, operates by plugging in all the probabilities, squished up into more broad categories. But one flaw of it, from a perception standpoint, is that we do have good guesses for many of these variables in Drake's equation, and we tend to assume the ones we don't are equivalent. That's a thinking flaw along the lines of calculating the odds someone will have, let's say, a nice plaque on the wall. If I tell you the odds of them having that plaque depends on 4 factors, A, B, C, and D, and I tell you A, B, and C are all about 1 in 10 each, you would tend to think D must be too. For about a 1 in 10,000 chance and figure out of 7 billion people, there must be hundreds of thousands with that plaque. If I now tell you A is the odds of being an athletically inclined male, B is living in a quarter hilly environment, and C is enjoying the hobby of skiing, all seems well. But when I next tell you that we are solving for the number of people who have a gold medal in men's alpine skiing, you now realize why it isn't hundreds of thousands, and why D, getting into and winning the Winter Olympics, is not a 1 in 10 option. One of the reasons we went through that long list was to emphasize why you need to distrust your intuition when looking at Drake's equation. Rare Earth and Great Filter approaches both argue some of these variables are much, much lower than others. Moving on to Category 1C, Civilizations Don't Last Long, is often better phrased as including the notion that they don't go out and take an interest in the galaxy, as the Fermi Paradox is about spotting these guys, which is hard to do if they blow themselves up, and much easier to do if they expand out into the galaxy or like to talk to others, or shoot missiles at them. I separate this from the prior two subcategories because steps 49 and 50, not blowing ourselves up and colonizing the galaxy, are steps ahead of us, not behind. A lot of folks like this camp because it lets us assume getting where we are now isn't very uncommon. I don't, and honestly probably a third of the videos on this channel examine that notion. I consider it needlessly pessimistic, and actually quite unreasonably so. I wouldn't be surprised if quite a few civilizations did blow themselves up, or did decide interstellar colonization wasn't for them, but I would be surprised if virtually all did. And it's hard for me to imagine that if intelligent civilizations are so common that they pop up around only even 1 in a million stars, meaning there'd be nearly 500,000 in the galaxy, that not a single one of them managed to both not kill themselves off and stay at home. We talked about this more in the Dyson Dilemma, but we spent a good half hour discussing number 49, self-obliteration, in the Apocalypse How video, and we'll be looking at that more in the Carter Doomsday argument, where we'll also look at some of the more strange ways civilizations could take themselves out. For number 50, colonizing space, we have a whole series on this channel that looks at how you could do that, including at everything from moon bases to terraforming and interstellar colonization. And we talked about why you would, and why it would be very hard not to, in the Dyson Dilemma. But the fundamental argument of this camp is that technological civilizations find ever more potent ways to blow themselves up, get ever better at making those easier for smaller groups or even individuals to get their hands on, and tend to have more and more people, out of which lunatics for instance might pop up who would cheerfully kill everyone. Needless to say, this was a very popular camp on the Fermi Paradox during the Cold War, especially before we landed on the moon. And even though the Cold War is over, we have figured out more ways to kill ourselves and we haven't been back to the moon, let alone establish colonies on it or other planets, in nearly 50 years. You can check out the aforementioned videos if you want the various counter-arguments. Category 1D will finish out our first category, and it is the notion that life, or intelligent life, just doesn't even occur naturally. That it can only happen through an event so implausible it is less likely than not to occur during the entire existence of the universe and the entire extent of the universe. Obvious inclusions would be God did it, or aliens from some prior universe or external reality did it, or that we are living in a computer simulation. From a practical standpoint, these are all equivalent statements. We look at this more in the simulation hypothesis video, so I'll gloss over it now to save us time. The big weakness of them is not the obvious one, lack of evidence. Every Fermi Paradox solution suffers from that. Their weakness is that they're not internally provable. God, or the great programmer in the lab above, can pop in and tell us they made us. We can't force them to tell us, and in fact, they could easily just upload the last stable version of the universe if they drop the ball and actually give away the show. As to life just being astronomically improbable anywhere in the universe, we have only the anthropic principle. The reminder that only universes where we won the tiny freak odds to exist will actually include anyone who can notice that. Doesn't matter if the odds of life anywhere in the universe are 1 in 2 or 1 in a gajillion. Only universes where someone won the lotto will have anyone around to notice it. And there's always a finite chance for life. No matter what else, there's a chance of particles randomly assembling itself into not just self-replicating molecules, but a full-blown intelligent creature called a Boltzmann brain. Now the strength of 1D is the same as its weakness. It's hard to disprove. Even arguments like why would God or the great programmer make a giant universe for one species don't hold up very well for the same reasons a few bacteria in the middle of a petri dish would be wrong to assume there must be more bacteria elsewhere in the petri dish. We put them in there for them to grow. We don't care that it will take a few hours or days for them to fill it up. So that's category 1. We haven't seen aliens because they are terribly uncommon. The shared strength is that it's logically consistent. There's no huge gaps in it. Its big weakness is that the lack of evidence weighed against the sheer size of the universe and the mediocrity principle, the notion that when you only have one example of something you should assume that it's pretty normal or mediocre. Category 1 can rub people the wrong way exactly for that reason. The other name of the mediocrity principle is the Copernican principle, and Copernicus is the guy who got us thinking that we weren't the center of the universe, that we can't think that way when trying to be rational and objective, and so Category 1 seems to fly in the face of this core and founding principle of science. Okay, let's finally advance to our second category, the notion that aliens aren't that uncommon, we just can't see them. Now as I said with Category 1, it isn't that people in one category can't think life is necessarily super common. Many Category 2 folks do subscribe to Category 1 thinking, but it isn't the focus of their Fermi Paradox solution. I divide Category 2 also into 4 subcategories, though quite a few of the special cases we'll look at in the Miscellaneous category arguably fit in here too. Category 2A. They talk, but we can't hear them. Category 2B. There hasn't been enough time for us to hear them. Category 2C. They don't talk because they have no reason to. And Category 2D. They don't talk, and they actively hide also. Category 2A, that they talk but we can't hear them, can be looked at both from the SETI Institute perspective, that we need bigger ears and patience to pick up their signals, and also the general notion that they talk using a means we can't listen to. This would include both mundane methods like using directional lasers rather than omnidirectional signals, and that they use some faster than light method we can't pick up, same as guys in the 18th century wouldn't know we talked by radio waves. Now this is a very popular Fermi Paradox camp, and quite probably the largest amongst those who are just giving the matter casual thought. Unfortunately, it has a couple big weaknesses on examination. The big one is the absence of what we call teaching beacons, or sometimes Benford beacons for James and Gregory Benford. Basically the notion that any civilization that wants to be heard can be heard. A friendly civilization that wants to broadcast so that radio-capable civilizations can hear them can yell loudly enough to be heard galaxies away, even using an omnidirectional old-fashioned radio signal. And even if for some reason not every civilization develops radio on their path to the stars, most will. It's pretty much impossible not to figure out how radio works and use it for astronomy if nothing else, and still get yourself up to spaceflight technology. So most civilizations will know it's a common method of sending signals. That's an example of exclusivity, another thing we'll bring up a lot in Category 2. It is maybe possible someone could become spacefaring without understanding either electromagnetism or math, but it's not very likely. Spacefaring can be considered a trait exclusive to species that understand those two things. Alternatively, we couldn't say you need to be capitalist or communist, oligarch or democratic, religious or atheist, to get into space, since on Earth the first two groups that did that were the US and the Soviet Union. So we'd say that the trait of spacefaring is not exclusive to any given political, religious, or economic system. That will come up a lot, this non-exclusivity concept, in many of the Fermi Paradox solutions after Category 1, because many of those solutions rightfully look at means and motive for expansion or communication. And if you can't argue that spacefaring is exclusive to that behavior, it doesn't hold up well. We were never interested in how one single species would act, where that action would leave them undetected, if we can assume others won't act that way and be detected. Now for radio signaling, this also assumes they haven't got something better, but again would only work if they only want to talk to those who also have it, akin to the Prime Directive from Star Trek. That sort of notion we'll address in the Miscellaneous section, that they don't talk to primitives on principle. If that ethical issue isn't in play, waiting doesn't make much more sense when you can just send them blueprints for a way to talk. This of course assumes they have something better than radio. And by better, again, we could mean directed lasers, but what people usually mean is faster than light communication. Now we've got a series focusing on that subject, and there are some ways it may be possible. But the current thinking is that it is not, and it really only makes things worse if it is. Faster than light travel communication comes up a lot with the Fermi Paradox, and it pretty much only ever makes it worse. If you can leap from star to star in days, not years, or instantly, besides being able to visit or colonize places very easily, you can also just dump local satellites near inhabited planets, chirping out a hello and instructions for how to contact them if you want to. And you might think deploying a satellite around every star in the galaxy, or just the ones you've noticed have advanced life on them, is a hard task. But when we're talking about advanced civilizations, it would barely count as a minor budgetary item. I haven't mentioned the Kardashev Scale yet. I don't actually like it as a scale because it's a very narrow spectrum and all about energy, but it's a popular term for describing high-tech civilizations. We would rate as about a 0.8 or 0.9 on that scale, and if we used all our planet's energy, we would be a 1. If we used our whole sun's energy, like with a Dyson sphere, we'd be a 2, and using a whole galaxy's power output gets you a 3. A Kardashev 2 or K2 civilization, even with just our level of tech, could easily build a transmitter that you could pick up on your car radio and could churn out 1 trillion satellites like a G20 country could produce a box of pencils. A K2 civilization is usually assumed to have about 1 billion to 1 trillion times as many people as us, and a K3 about the same to them, meaning a K2 civilization could also devote 100 astronomers to watching each and every star in their own galaxy and still only use about 1/1,000,000th of their population doing it. The United States, population 320 million, employs more than 320 astronomers. It's actually about 20 times higher than that at 7,000. We usually assume advanced civilizations can devote more people proportionally to scholastic pursuits, too. That's worth remembering when we get to Category 2D, Aliens Hide, when we contemplate that anyone trying to hide from a K2 civilization knows that not even including any technological advantages they have, they're trying to hide from people who can casually devote several thousand times the entire human population to full-time searching and still have such a small portion of their population performing this task that most of their own people will never have met someone who does that job. So the strength of Category 2A is basically that it plays to our own ignorance. We don't know much about the universe yet, so it isn't outrageous to think we don't know how the grown-ups like to talk, and that they can't be bothered to talk to us. And again, it doesn't exclude that life might still be pretty uncommon too. The weakness is just that, we're not that ignorant. And we do actually like to talk to people who are, exactly because we do not think ignorance on a given subject equates to stupidity. We highly value knowledge and talking with others. That could easily be a pair of traits which are exclusive for spacefaring, since a value for knowledge and sharing and conversation would seem pretty important to developing technology. Again, we'll discuss the notion they feel morally obliged not to talk to us in the miscellaneous category. But the notion that they wouldn't find us interesting enough to talk to, when it would be, at most, a minuscule inconvenience, just doesn't hold water, though we'll look at it a bit more in 2C. Before that, we've got 2B, that there just hasn't been enough time for us to hear them yet. Now, fundamentally, this is the SETI Institute line of reasoning. Aliens aren't very common, probably not expansionists into space, and probably don't go to huge efforts to talk loudly. This is a very strong line of reasoning, especially if you tend to tilt towards Category 1C, that civilizations don't last long or expand. It also assumes faster light travel isn't very likely. Light takes a long time to get anywhere, and signal strength falls off with the inverse square of distance. Double the distance, quarter the signal strength. 10 times the distance, 100th the strength. It's also temporary, only on while transmitting plus light lag. It's like detecting a wave from dropping pebbles on the far side of a large pond. You need to be looking closely at the right place, at the right time, to spot them. I said a couple minutes ago that anyone who wanted to be heard could be heard galaxies away, but I'm assuming someone who has passed the Kardashev 1 stage of things. A transmitter that can be easily heard across an entire galaxy takes an absurd amount of power, tiny for a K2 civilization, and infinitesimal for a K3, but a lot compared to what we use nowadays. You have to be around long enough to have an established infrastructure in outer space to do stuff like this. If everyone is only transmitting at the megawatt scale, and only for a few centuries each, you could easily have millions of species popping up to our tech level, transmitting for a few centuries, then dying off before building anything bigger, or talking long enough for someone else nearby to pop up and hear them. The Hawk conjecture, and Hawk-Tipler conjecture, which we talked about more in the Dyson lemma, thud into this by arguing that it should be possible to expand out into space, and that aliens would generally want to. If both are true, Category 2B gets blown out of the water. Civilizations last a long time, indefinitely, and can absolutely talk loud enough to be heard. So 2B is a good solution if you tilt toward Category 1C line of thinking but want to add on. Now there's a non-scientific, but valid argument against SETI out of this too, which basically argues that if every civilization ends up sitting around on its own world till it dies, why would we even want to hear from them? That's not an argument against it being true, but it is an argument against operating as though it was, since not only can they not give you any useful information on avoiding your own self-destruction if it inevitably happens to everyone, but listening to them could easily bring it about that much sooner when we pick up from them how to make some sort of really great technology on the surface that results in inevitable destruction when employed. Often called the honeypot or suicide pact technology, I discussed this in the Apocalypse How video in more detail. Now Category 2C is the idea that aliens can talk to us, have no moral objection to doing so, but simply don't want to. They have no reason to, so don't go to the effort. I'd argue this doesn't work too well because it would seem weird any alien civilization, let alone every member of every civilization, don't feel like talking to us. The usual analogy is that they look down on us like we do to ants, But that's a bad analogy considering we spend tons of money and research time studying ants, and would talk to them if we could, and we talk to our pets all the time. And why would anyone stop someone who wanted to talk to technological primitives anyway? I mean, we don't encourage people to talk to their goldfish, but we never ban it, since there's no threat to us from them doing so. We are not afraid of goldfish, and advanced civilizations couldn't possibly be afraid of us. Now, the other line of reasoning is that they just don't value anything we have. That's plausible from a purely rational line of reasoning. We can't offer them better technology after all. But again, it's hard to imagine curiosity as a rare trait in spacefaring cultures. It might not be exclusive, no high technology without curiosity, but uncommon? Not likely. And again, with such things it doesn't matter if some do it, it matters that some don't. A race, even most alien races, might be incredibly indifferent to primitive alien art and culture, but it's hard to imagine there's no anthropologists except the ones who live on Earth. So I usually consider 2C a very weak Fermi Paradox solution, and it's not a popular one in terms of being vocally defended, but it makes the list because it's a common knee-jerk suggestion. They just don't have any reason to talk to us, so they don't. And again, the idea that they are morally opposed to it, and therefore might stop anyone from doing it, from talking to us, we'll look at in Category 4. Here we mean simply indifference as a motive. Too much effort, not enough gain, no conversation, and the weakness is that curiosity ought to be a common trait in technological civilizations, so a massive lack of it would be strange. It also has the issue that it ignores that active communication isn't our only way to detect people. Technological civilizations leave a lot of fingerprints lying around too, which is very important to the next category. Category 2D is the idea that they do have a very strong reason for hiding from us and everyone else too. This is a very strong argument from a strictly biological standpoint, but breaks down strategically. The reasoning goes like this. Nothing, not one single thing that claws its way up Darwin's ladder is a wimp, or an idiot, or indifferent to their own survival. If you're walking around a dangerous park late at night, the last thing you want to do is yell out, "Hello, I'm weak and vulnerable, is anybody here?" And the last thing you want to hear is, "Yes, I'll be right there." Space is a big dark forest, and we tend to be worried about walking around being seen and heard because something big and scary might attack us. And it doesn't help that we also know that one lone human walking around a forest at night can walk with confidence knowing they are the scariest, most dangerous thing in the woods. Our minds, combined with our technology from having those minds, makes us super predators if we want to be, and that will be true for every other species. So it isn't hard to imagine one that is older and nastier might be hanging around listening and waiting to pounce. Maybe they hate all other aliens on principle. Maybe they just don't want to share and are ruthless. Maybe they've racked up so many acts of genocide that they feel they have to keep doing it just to make sure no one ever gets powerful enough to find out about their prior crimes and hold them accountable. Extrapolating from that, it's not hard to reason that whatever benefits you might get from shouting out to the universe hoping someone will reply, when all appears silent, doesn't outweigh the risk of exposure. This is the main argument against METI, also called active SETI, or messaging extraterrestrial intelligences. Now what's wrong with it? Well, basically that technological species aren't wimps or idiots. They will understand strategy, and silence isn't a great one in the long term. Ask yourself what you would do if you were a species hell-bent on wiping out everyone else. I know what I'd do. I'd expand my civilization like crazy to maximize my resources, infrastructure, manpower, and research pool. I'd push for a K2 civilization as fast as possible because, as I mentioned earlier, I could devote hundreds or even thousands of people to studying every single solar system for signs of life. Even if I didn't expand outside my own solar system for some reason, there's no such thing as a K2 civilization that could not detect us, as we are now, anywhere in the galaxy, and kill us from there. Just as you could build a transmitter powerful enough to be heard across the galaxy on people's car radios, you can build a detector that can pick up our own transmissions. You can also build a directed energy weapon, a Dyson beam, able to blast whole planets on the other side of the galaxy and keep flicking that beam from world to world, hitting every planet in the galaxy in less than geological time. Nor do you have to wait for radio. You just burn any planet that looks like it might have life. This all assumes you aren't just expanding and taking those worlds as your own, which would also seem a logical course of action. It's also very hard to hide if you decide to do so. You leave fingerprints, your heat signature mostly, but without specifics the reasoning would be like a Bronze Age civilization trying to hide from us. They know they can't, not forever, and they know when we find them, all that effort they spent hiding could have been better directed at building up their own size, technology, and defenses, spreading out to be less vulnerable, that sort of thing. So when a civilization has been hiding and not expanding when they could, spending uncountable resources trying to hide better while doing it, eventually someone will ask one of their generals. Probably a very good one too, since such a civilization would presumably value strategic thinkers who could help them hide better. And he will say, "This is futile. It's been 1,000,000 years we've been hiding and we've seen and heard nothing. Either no one is out there, or they're all cowering like we are. If someone wanted us dead, they'd have had us so by now." Only in fiction do technologically and numerically superior enemies lose, especially if they are passionately dedicated to killing their enemy and don't give a damn about collateral damage. So they stop hiding, and they get detected by other people hiding, who make the same decision and everyone starts talking. But it wouldn't take 1,000,000 years. We already know we've been detected by anyone with a desire to see us and close enough to care, and strong enough to hurt us. So we will never operate with the intention of hiding if it costs us anything, even just missed opportunities, because it's wasted effort. That's Category 2D. Aliens hide because they're afraid of bigger predators. The big counter-argument isn't that they shouldn't be because no one might have malicious intent, but rather that they shouldn't bother because if anyone does, hiding won't help you. And that closes out Category 2. The individual strengths vary, but the key weakness is the same. It relies too heavily on people's motivations and frequently breaks down when those lines are shown to be either logically flawed or violate the concept of exclusivity by requiring behavior we have reason to think would be present in all technological civilizations. Category 3 revolves around the notion that aliens exist, but we can't recognize them. And again, I use the word recognize here in multiple senses. And also again, we have 4 subcategories. Category 3A. Aliens walk among us, but hide themselves. Category 3B. Aliens used to walk among us, and helped us develop civilization. Category 3C. Aliens walk among us, don't hide, but are so alien we literally don't recognize them. And Category 3D. Aliens walk among us because we are aliens ourselves. Category 3A requires little explanation. In fact, we'll be flying through Category 3 pretty fast compared to the last two. There's no way you're alive today and have access to YouTube without having seen 100 fictional examples of this, and many people believe aliens walk among us. I've better things to do with my time than ridicule that belief, and it wouldn't be fair to either, since unlike the other categories that so far have no proof or evidence either, this one actually does. The problem, of course, is that we don't believe that evidence is valid. There's tons of evidence for ghosts and pixies and goblins too, but hard scientific evidence is lacking, and what is also lacking for the other categories, they suffer from not being able to gather much evidence yet, whereas evidence for 3A, Aliens Among Us, is lacking while it all takes place on the one spot in the universe we actually can model and collect evidence from easily. Proving there's an elephant or 900-pound gorilla in my living room is a lot easier than proving there's one somewhere on the entire continent of Africa. The usual line of reasoning, though, is that the government covers it up, and this was really popular in the 90s. It's kind of hard to imagine that every government conspires together to do this, especially considering how crappy governments tend to be at keeping secrets. Now, of course, the conspiracy-minded tend to think otherwise, and I obviously won't sway them, but I also ask you to consider motive. I could give you a laundry list of reasons why no aliens need to hide among us if they have malicious intent, beginning with the simple fact that an interstellar capable species could flatten us like a bug, but I can't think of any benign reasons besides anthropology that they'd hang out here secretly, and I wouldn't think they'd chat with our government about it, or feel the need to abduct people and perform proctology exams on them. Category 3B is the notion that aliens used to hang out here, usually pretending to be gods and helping us get started. Ancient alien astronauts. This was a concept popularized by the 1968 book Chariot of the Gods, and it's a very popular notion. Tons and tons of fiction, often very good fiction too, revolves around this idea. But the problem is the evidence presented always involves things that we know our ancestors could have built. Contrary to popular belief, we know, and have known for a long while, how to build the pyramids using that era of technology. We never thought it was impossible, and the debate was over which of several possible methods they would have used. Great stuff too. It's frankly amazing how innovative our ancestors were with their ancient monolith building, and a subject I'd encourage you to read up on. That's probably why this category rubs me personally the wrong way too. I dislike the notion of stealing away our ancestors' accomplishments and dismissing them as stupid primitives by saying they needed external help from aliens. But that's a matter of opinion and bias, I suppose. Evidence-wise, there's two problems. First is that none of those things require advanced technology. There's no lighthouse kicking around from 2000 BC powered by a passive nuclear reactor, for instance. Second, you always have to wonder where they went. Now, civilizations do often die out, but only kind of. They get replaced. Rome may have fallen, but the Roman Empire trucked on in the east for centuries, and fell to another empire when it did go down. And in the meantime, Rome rapidly recovered and remained a political, cultural, and religious influence of the highest degree all the way up to today. When we say a civilization falls, we don't mean its whole populace and influence disappeared. Usually it's just divided up, moved its capital, dropped to second-tier status, resurged later with modified territory and culture, that sort of thing. So where are these ancient aliens now? One possible answer, that they've ascended to a higher plane of existence, as it were, we'll look at in Category 4. Category 3C takes a different direction. It considers the possibility that the aliens are so alien that we just don't even realize they exist, or exist as intelligent entities anyway. And possibly they have the same problem with us. The very alien is an interesting line of reasoning, and played with most humorously in Terry Bisson's short story, They're Made Out of Meat. Giving serious examples of the ultra-alien is obviously tricky, and that's one of the weaknesses of this category. When we posit, for example, an intelligent tree, we can easily picture how we can't see it, or it us, as intelligent creatures. The problem is when we examine the notion of an intelligent tree, we not only have to deal with how improbable an evolutionary development that is, but also how we probably would be able to realize it was intelligent. If it's mobile, either able to pick up and move or stays rooted but can swing its arms, we ought to notice that, and would certainly notice physical structures inside the wood indicating that. If it isn't, why would it evolve a brain? Brains are expensive after all, and start off its crude nervous systems to react and move. Evolution doesn't encourage useless organs. The strength of 3C is that it simply isn't disprovable. The weakness is that it's pretty much impossible to usefully discuss. It's one of those how can we know for sure, or anything is possible arguments that isn't exactly wrong so much as just sort of futile to discuss as anything more than a thought experiment. Category 3D is our last one before getting into the miscellaneous material, and it raises the idea that we ourselves might be alien in origin. In this context, I'm not talking about panspermia in the sense of basic life originating in comets or the Oort cloud and raining down on early Earth, but the notion that intelligent life actually made humans, either directly or by starting life on Earth. Very popular notion in fiction, and a fun one, but it has some obvious problems. Like ancient astronauts, you have to wonder where they went, and if we're talking about just humans, then you have to wonder why our DNA is so like everything else's. Sometimes the reasoning will be that we're just an abandoned colony of a falling civilization that turned primitive. Sometimes they just popped by and gene-tweaked our ancestors to be smarter. As usual, there's the whole lack of evidence thing. But the notion has some strengths. You could terraform a primitive world just by sneezing or emptying your septic tank on your spaceship. Even our bacteria are quite sophisticated compared to primitive ones and would probably get the upper hand there and replace things. The specific weakness, though, is that it establishes that aliens are prone to expansion and capable of it, yet nobody is out there doing it. Most Fermi Paradox solutions that don't revolve around intelligent life being rare to begin with usually need to explain why aliens can't or won't expand and colonize all over the place. This one begins by saying they did. So what changed? Why did they stop, and why hasn't anyone picked up where they left off since? Summarizing Category 3, we see the big shared weakness is fundamentally the lack of evidence. And again, the lack of evidence from the one place in the universe we can most easily gather it. Theories revolving around evidence that is hard or impossible to get deserve a bit more credence than ones that make it easy to get but still lack it. Now for those of you still here and awake, we get to move on to the miscellaneous category. I promised myself I'd keep this video shorter than the original, especially with so many supplemental videos I could forward people onto for more detailed explanations, thus letting me skim some topics, but even though I repeatedly and energetically trim material from the script, I see that it's still going to be a broken promise. So here they are. Category 4A, the zoo hypothesis, quarantine, and the prime directive. They specifically hide from us, or primitive cultures in general, for various reasons, as opposed to Category 2D, where they hide from everyone. Category 4B, interdiction. A variant on 4B, where civilizations agree not to expand, or expand beyond a certain point. Category 4C, self-quarantine. Species actively keep to themselves for fear of contagion. Category 4D. Living civilizations are very recent, living being the focus there. This is the category for cyclical extinction or a very recent galactic-wide extinction. Category 4E. Ascension. Aliens reach the point where they just leave the mortal coil behind. Category 4F. Civilizations reach technological singularity. Civilizations convert totally to the post-biological state and into a super advanced and super powerful computer. Category 4G. Rim migration. Civilizations eventually migrate to the colder outer areas of the galaxy. Category 4H. Black hole farmers. Like rim migration, a notion that has to do with concentrating your civilization where you can get the most bang for your buck. Those who have seen the original video will notice some changes and removals. There's a couple add-ons or modifications, and a couple removals because I didn't feel they really had anything but humor value. There's also 3 general themes in Category 4, one being that civilizations move on, another that they have rules for dealing with each other that prevent contact, and the third being that they get destroyed. We'll save the first one for last, because I feel like the concept of civilizations moving on is a nice way to end the video. Category 4A, generally known as the Zoo hypothesis, is very like quarantine and the Prime Directive in that it holds that alien civilizations have a motive for keeping us in particular, or low-tech civilizations in general, in the dark about their existence. Those motives can vary. For instance, in Zoo hypothesis, that can be anything from not wanting to interfere in our natural development to using us for entertainment, or both. There's no reason you can't enjoy watching a primitive culture just because you want to keep it safe. Alternatively, quarantine holds that their motive is that they want to keep everyone safe from us. The Prime Directive variant is that they aren't actively hiding, they just refuse to show themselves until we reach a certain level of technological or cultural development. Now, Zoo hypothesis is a bit hard to dismiss when it holds to them faking us out with, for instance, a big TV screen around our planet or solar system. But that's much the same as the simulation hypothesis I mentioned way back in Category 1D, and you can look at that notion in more detail in that video. Specific to the Zoo hypothesis, though, is the criticism that since we derived the entire Fermi Paradox in the first place from seeing how big the universe is, if that image is fake, it sort of challenges the core concepts of science we derived the paradox from. Quarantine, that they are afraid of us, suffers from not just making much sense. Usually it means they're afraid we'll infect their culture with our violent ways. I'm not really sure how to argue that since it implies advanced civilizations are made up of a bunch of wimps with no moral backbone. I'm not afraid teaching kids about our nastier cultures that were into human sacrifice or genocide is going to turn them into axe-crazy murderers. And I have problems thinking of any advanced civilization, let alone all of them, being afraid of inheriting our violent ways. Now, the Prime Directive is a tricky one, mostly because people are very passionate about the subject. It's dead on arrival normally from exclusivity. We have no reason to think every civilization would think you shouldn't talk to primitives, quite to the contrary, and we especially have no reason to think every member of every species would obey this, and it really only takes one person to break the silence. Category 4B, Interdiction. The notion here is very like the last category in effect, but different in motivation. Expansion isn't rampant because species agree to large buffer zones, and they don't talk to other low-tech races because they've agreed not to on the grounds that they don't want their potential rivals or enemies poisoning the primitives' minds about them, and they generally think conflict is best avoided by avoidance. Stay away from aliens. You can never entirely get them, and it's easier to get along with minimal contact. Everyone agrees to keep themselves pretty small, so nobody has a motive nor ability to go to war. This one doesn't assume any particular motivation besides caution, which doesn't violate exclusivity since we can assume that, like curiosity, caution is a trait probably shared by all technological civilizations. There's also good reason to enforce it, and it's easier to enforce it with all that buffer space. Now, it's still got its problems, same as the others we just covered, but they aren't as strong. You still have the issue of newly emerged spacefarers getting angry nobody gave them technology, but the counter-argument seems a little bit less smug, maybe. We agreed to this treaty, it's been around for a very long time, before us, and even if we didn't think it was a good idea, we don't want to suffer the consequences of violating it. This rubs some folks the wrong way because they figure we ought to be able to talk to anyone, be friends with everyone. But interdict doesn't say you can't chat a bit, just that it's gotta be kept distant and minimal. And realistically, getting along and tolerating other cultures is one of our cultural ideals that isn't too grounded in reality. We share common culture and biology, but still have a lot of cultural traits and traditions that infuriate or disgust each other, and that's not necessarily wrong. I don't want to go to war with a civilization that thinks you should deal with overpopulation by killing off everyone who doesn't get on the honor roll as a kid. And a lot of aliens that give birth to littles might have developed that habit and kept it long before some form of birth control was invented. I don't really want to be good friends with them either. It's much easier to stay away from conflict by just staying far away. I don't think interdiction stands up to scrutiny, but I think it's on stronger footing than the zoo hypothesis notion or quarantine. Now, category 4C is self-quarantine. This is where you isolate yourself, and it's like 2D, hiding, except you're not actually hiding. You keep to yourself, warn others to stay away, and don't permit much outward expansion of your own civilization, because you don't want mutant strains of your civilization popping up as possible threats. I talked in the Dyson Dilemma about all the problems trying to keep your own people from spreading out, but it is fundamentally doable. Spaceships, by and large, are not small or subtle. It would tend to be pretty obvious when someone was building one, and very obvious when they start flying off. The weakness here is the obvious one, exclusivity. We have no reason to think every civilization would act like this, but it also has another problem. If you want to keep to yourself, this doesn't mean you're super quiet. If I want people to stay away from me, I leave no trespassing signs around. Animals mark their territory too. So you'd expect big beacons saying, "Hi, stay away from our stuff. We're not hostile, but we like our privacy and are armed to the teeth. For urgent or vital diplomatic matters, please contact us at 867-5309. Total silence isn't a great idea if you want to be left alone, because people will blunder in unknowingly or out of curiosity, and if you blow them up, you haven't got much more ground to stand on when your neighboring civilizations find out you've killed their citizens. If you want to be left alone, it pays to be very loud about telling others that, not the other way around. 4D is the notion that civilizations just popped up recently, and not in the life has only been possible for the last billion years kind of way. Usually this implies either coincidentally a major calamity or war just happened and we missed it, or someone comes by killing civilizations every so often. Popular idea in fiction. They used it in the TV show Babylon 5, and they used it in the video game series Mass Effect, and plenty of others. Unfortunately, coming up with a motive for why this is done never makes much sense. Ask a lot of Mass Effect fans how they feel about the end of the third game, for example. Great for fiction. The idea of an ancient evil predator periodically arising to consume us appeals to our natural fear of predators. Bad for science. If you just want to wipe out every single life form in the galaxy, you can get it done a lot easier and keep it done. That implies someone is harvesting or culling folks. They obviously aren't literally eating us or enslaving us, and if they just want our culture or memories, that can be obtained without genocide. The other issue is the universe doesn't stop at the edge of our galaxy. If ours had these, well, we'll just call them Reapers, show up first on the scene, they obviously are not a true K3 civilization. So a galaxy where K3 did pop up could come blasty in here and smear the galaxy with them. And while we tend to think of the gulf between galaxies as vast and empty, galaxies are very close to each other relatively speaking, more like continents than tiny islands separated by thousands of miles of ocean like solar systems are. There's tons of stars between galaxies, possibly more than in galaxies, and while they are spread out and probably don't have a lot of rocky planets, they still make an easy bridgehead between galaxies even if you don't have faster-than-light technology. So at that point you hit exclusivity, because you wouldn't expect every galaxy to develop these Reapers with their bizarre and seemingly illogical motives. Category 4E, Ascension, is the first of what I think of as a sort of eschatological solutions. A staple of science fiction is that we eventually evolve into beings of pure energy or ascend to higher planes of existence. From a Fermi Paradox solution standpoint, this actually works just fine, so long as it is happening to every race and all its members, and before they spread out much. The strength of the next category, actually, which looks at it from a much more technological perspective. Now, Ascension has two big problems. First, we have no idea if such a thing is possible. It basically requires tossing all known science out the window, and honestly it always smacks way too much of a New Age religion to me. Which, if that's your thing, hey, great, but this also only works as a Fermi Paradox solution if they divorce themselves from the universe, which also always seems weird to me. I mean, from a fiction standpoint, you kinda have to have them do that. Stories don't work well when demigods hang around constantly able to fix all the problems with a snap of their fingers, but fiction isn't science, and that's why. Writers, even excluding their own biases or lack of expertise on a given subject, have to create a story that is interesting. We don't care if it sacrifices some realism to achieve that. But good stories don't make for good science just because they're thoughtful or fascinating tales. Second, we can't be sure they'd all do it, and in fact you'd expect they wouldn't. The Amish are one of many groups that, generally speaking, aren't too sanguine on technology, and I doubt that would change overall down the centuries. I can't see us ever pointing guns at our splinter cultures that reject the main culture or technology and forcing them to convert. And you'd actually expect a lot of these to be among the first to head out to colonize other stars. So civilizations prone to ascension might just have a constant expanding wave of those rejecting it and those accepting it. Same problem for Category 4F, technological singularities, but these frequently are envisioned as occurring very near-term, not distant future. We'll be examining the concept in the transhumanism and immortality video, but the strength is that it's not requiring any break with known physics. It's basically the idea of replacing your civilization with technological supermen or of one supermassive megacomputer. As we discussed in the Dyson dilemma, so long as it keeps a desire to survive and needs resources present in this universe to do it, the whole category is basically irrelevant to the Fermi Paradox. It doesn't matter if supermen replace us, any more than us replacing Neanderthals, as far as the Fermi Paradox is concerned, except that they ought to be way better at expanding if they want to. And again, as we discussed in the Compendium video, they probably would. We also addressed this notion of people hiding in virtual realities or digital existences there, and we'll be looking at more in the simulation hypothesis and transhumanism videos. Category 4G, rim migration, is actually an extension of the technological singularities. Once you've gone post-biological and basically run on energy and data, it helps to be somewhere that is cold. There's an absolute minimum energy needed to erase a digit, to perform the most basic calculation, and it depends on the temperature. Space actually isn't very cold, that's a source of confusion for a lot of people, but the depths of interstellar space are a lot colder than wherever you're sitting right now, yet it still isn't as cold as intergalactic space. The coldest anywhere right now is 2.7 Kelvin, about 100th of the temperature water freezes at, because space is constantly saturated by the cosmic microwave background radiation. Can't get away from it. But inside a galaxy, it's a lot hotter because there's all that ambient light and dust and so on keeping it a bit warmer. So we often figure giant computer minds move themselves out to the galactic rim, where they can get plenty of hydrogen still to fuel themselves, but can run more efficiently. The flaw is the obvious one. Even if everyone does this long before going interstellar, becomes a huge computer I mean, groups sharing the computer or single overmind, you still have to make the trip. Now you can move a whole star. We talk about that in the Megastructures video Chicago thrusters, but that's not a quiet process. And your thrust is pointing in toward the galaxy, so you're quite visible. You'd also wonder why they are bothering while there's still a galaxy to harvest. I mean, sure, efficiency is great, but which is better? One star you get maximum efficiency off of, once you spend all the time and energy moving it out to the rim or getting out there and using one already there, or several billion stars, each of which you maybe get half the computation off of, all much closer at hand, too. Category 4H, Black Hole Farmers. Wow, last category. Okay, here we go. We've talked before about using black holes as power sources, but we meant small artificial ones. This time we mean big ones. And it's less of a Fermi Paradox solution than a sort of final scenario for when all the stars burn out. This is sort of an extension off rim migration in that it revolves around getting the most computation you can off a single drop of energy. Not just computation either. Thermodynamics always involves getting your most efficiency when you're moving from hottest to coldest. We talked in that video about how black holes are thought to slowly evaporate by Hawking radiation. Those were small black holes though, ones vastly smaller than any we expect to exist. Naturally occurring ones are far too massive to evaporate right now. They gain mass simply by absorbing cosmic microwave background radiation since they emit less Hawking radiation than they absorb by that. Only black holes with a total mass less than our moon actually radiate more energy than they take in from the CMBR, and those are several million times less massive than naturally occurring black holes. One day, a long, long, long time from now, when all the stars have burned out, the universe will have cooled down enough that those big natural black holes will emit more energy than they take in, and that will probably be the final and longest phase of life in this universe. Civilizations will huddle around these black holes, slowly drinking in the energy, which is very small but super efficient, creeping along very slowly but for a total duration that would regard the entire history of our universe like an eye blink. And if you're digital, and you run on computer power, who cares how long passes in real time for you to have a conversation? Only your subjective time matters. These sorts of black holes are very easy to find or make, and it would not be strange for civilizations to stockpile resources by dumping hydrogen right into black holes. You could use the gravity pouring them in to power your civilization pretty well too. Now why this doesn't make a great Fermi Paradox solution is that it should be pretty obvious someone is doing it. And even though you're planning for the ultra long term, patience is not a virtue here. Every second suns burn on is energy wasted for you, never to be recovered. It's also whole galaxies drifting away far beyond where you'll ever be able to reach them to harvest. But I get asked a lot where I think civilization will eventually go, and I tend to figure it's probably this. Eventually, you can't live on sunlight anymore, and you fall in black holes instead. It seems like a real dark and cold existence, but in reality, it would probably be incredibly vibrant. We'll talk about them more down the road once we've looked at some other subjects. These kinds of final civilizations can keep existing for truly immense stretches of time, but of course nothing lasts forever, and everything eventually comes to an end. And on that note, I think that's where we'll wrap up for now. Wow, new record for video length. For those of you still here and awake, thanks for tuning in. Questions and comments are always welcome, and if you still have the energy for it, try out some of these other videos. If you enjoyed the video, hit the like button, share this video with others, and subscribe to the channel for alerts about new videos. As always, thanks for watching, and we'll see you next time.